Okay, so Al and I were talking about taking one of the power steering units, the electric power steering units, and being able to control that directly from the computer, as opposed to right now what's being done is you bolt on a power steering unit which has an electric motor and it's got a control box on it, but the control box is being disconnected and driving the motor directly. So people went out and bought the Cytron 30 amp H-bridge driver, and you plug that into your motor, and then from your microcontroller you can say turn it left or turn it right by applying PWM to the motor. So then by adding a potentiometer to the steering system, you can do a closed loop system where you say turn it to 10 degrees or 20% or whatever unit you're using on that, and you can get the steering to work. And then Al was saying it sure would be nice to use the existing control unit that comes with these things. So I think it was last week's Friday meeting, we discussed that briefly. So I spent several hours digging for this information because there doesn't seem to be information available. But it turns out that if you get the power steering unit that Al and Matt have right now, which is the one off the Saturn Vue, which turns out I have a Saturn Vue that I can do some experiments with if I have to. But it turns out that one, for some reason, Chevy decided that you need to, when the power steering unit powers up, it has to go out and get information from somewhere else before it'll go into this power steering mode. So what some guy did, and he was like from Bulgaria or some other country, somewhere out of the country than where I'm from, he built a little box. So if you go out on eBay, you can buy this little controller box, and it will, you plug it into your system, and that then puts it into what some other guys call this fail-safe mode, and I'll get into that in a second. But basically, by putting this box on there, then you apply power to it, and it just works as a normal power steering unit. So you can just grab the steering wheel and turn it back and forth, and that turns your wheels and gives you the power assist. And I thought, well, since this guy's putting that out, there's got to be lots of information out there on how to do that, because it wasn't obvious what's there. And when I started digging into it, I kept digging and digging and digging, and finally it turns out there's a serial bus that goes from the power steering controller on this Saturn / Chevy, whatever that's called, Chevy Cobalt. It's right there. Matt just posted that. On that unit, there's a serial interface that when it powers up, it goes out to, it's either the engine control module or the body control module. Somewhere it's got calibration values that are saved. And then also while it's running, it's got some kind of speed dependent steering assist. So the faster you're going, the less assist that it provides, which gives you better feel and just makes it work better. So my guess is this guy that made this module went in and sniffed out this serial interface bus and put a microcontroller in his little box. So when you power up, it talks back and forth to the steering controller and says, here's your calibration values you want. And then it may, as it drives along, as you go on, it may say, here's my current speed, even though it's just a made up speed. So it looks like in order to get that one to work and use it as a power steering unit, you have to do this. You have to add this external module to keep the controller happy. And then when I did some more digging, there's another guy that put out, if you search for $35 power steering fail-safe, if you search for that, he's got articles everywhere. It's like they copied it, 20 times. It keeps showing up. But he made the comment that if you buy the cars that have the Japanese type power steering, which is like Nissan and Prius, so that's what Toyota and Nissan at least, they have these units that basically you put your 12 volts, you connect it right to your battery, and then it's got an ignition line coming into it. So once your ignition turns on, the thing automatically, it's looking for either a CAN bus message or whatever the serial data is coming in. And if it doesn't see that within a certain amount of time, like 10 seconds or something, it just goes into this fail-safe mode and becomes a power steering unit. So in that case, you don't have to go out and buy this $50 module to put on this thing. So either way, by bolting one of these two types of units onto your vehicle, whether it's a garden tractor or a full-size tractor or whatever, if you get the Chevy one with the external controller box, or you get the Nissan type that does not require an external controller, you've now got, you could add power steering to your garden tractor or big tractor or whatever you're trying to run. So then I did some other digging, and it turns out the way these things work, they have torque sensors built into the steering. So between your steering wheel and the motor unit itself, there's a torsion bar that's in line there. And they've got a torque sensor on the input of that and on the output of that. And from what I could tell, at least something from 2005 I was looking at that point, they were putting out, it just puts out a voltage. So you've got two torque sensors on either side of that torsion bar, and they put out, if you're not touching it, they put out like half a VCC, so it puts out like 2.5 volts on both of those. So that feeds into the controller, and as long as those voltages are equal, it's happy and just sits there. But as soon as you turn the steering wheel, it twists the torsion bar just enough that you've got the two pieces like this, and you turn the steering wheel, it turns this a little bit, and it detects that as moved, so the voltage on that one changes, and then it turns the motor to bring it around to the same point. So if the modern ones still work that way, it's probably just a matter of going in and you could add, you could put a voltage of say 2.5 volts into your algorithm, or actually you probably, let's see, do you need to do that?
Yeah.
Since that's a torsion bar in between there, you could probably just ignore the two of them and just take the one. Well, no, actually, I guess, because we're not going to be doing real power steering. We just want to fake the motor out to get it to turn. So into the controller, you put 2.5 volts on one input, and then the other input you just control from one microcontroller. If you make it higher than 2.5, it's going to turn one way. If you make it lower than 2.5, it should turn the other way. And some more digging I did, I found a schematic somewhere that, unfortunately, it was from one of these articles that they post, like on Springer.net or whatever, and it was the picture from it, but the original article was gone. So I was looking at the schematic, and they basically have a microcontroller. I think it was a microchip microcontroller and a microchip CAN interface transceiver. And then basically he showed the connections of, he said, here's the two torque sensors, and then they plug into the controller, and then the other side of the controller, he showed a cable going off that had CAN and power and various things. So what his whole point was, he added, somewhere in the circuit, he had 2 relays in there. So apparently when this thing powers up, if it's happy about something, then it switches the relays to switch from, instead of using the torque sensors, it switches over to using the microcontroller. And on the microcontroller, he had 2 PWM outputs, and he just simply integrated those with a capacitor and a resistor, and then used an op-amp voltage follower. So basically he was converting the PWM from the microcontroller into a voltage, and then he's feeding those 2 voltages into the controller. So basically he showed the entire circuit there, but I have no idea what the code was he's using, because all I had was just a picture of a schematic at that point. But it seems like you should be able to make this work. So either with the Chevy one with the external $50 box to keep it happy, or buy the other one. This guy said he was getting the quote Japanese fail-safe ones for $35 at his local junkyard. When I do a search on that, they seem to be a lot higher price than that if I look on eBay. But if you can run across one of those, that way you don't have to spend the extra $50 just to make it control. And it could be, if you look far enough, that some of these might even have built-in angle sensors built right into the steering, so you wouldn't have to add one on externally. But I haven't got that far. So I was thinking a couple of things I could do. No, if it weren't so cold out, I'd crawl under my dashboard, hook up a couple wires to my serial bus, and the first thing I do is put an oscilloscope on it, see, check the voltage. It's probably like a 0 to 5 volt logic signal, or it may be something like a CAN bus or an RS-485 bus. And I might be able to tell by putting an oscilloscope on what that is, so I can tell if the 2 wires are differential, or one's like a data line and a clock line, or whatever they happen to be. And then once I get that, then I can look at the actual data stream and try to determine, is it asynchronous serial, or is it CAN, or is it some like a version of I2C or something. And if I identify that, then I should be able to, I've got a logic analyzer that will grab the data. So you grab it for some amount of time, you apply a formatter to it, and you say, this is asynchronous serial. And it says, oh, well, here's what it's saying, if that's the type of data it is. And the last I looked, they did not have a CAN decoder for that, but I could just hook up a CAN to USB converter if it does turn out to be a CAN bus, and then I can see the CAN messages going back and forth. So one option would be buy the $50 module and see if you can open up and see what parts are in it, and then sniff out his bus, or just figure out what's going back and forth anyway. And you could theoretically, make up your own numbers to keep the thing happy. So the Saturn/Chevy ones, you possibly could make them happy by adding your own controller, or if you just start with the Nissan, Toyota type, as soon as you power them up, they're going to be running. So then at that point, I think you should be able to go in with your voltages and control this thing and make it run. And as I say, it seems like I figured there'd be lots of information, lots of people playing with this, and the more I dug, I found out no, the only one that knows how this works is that one guy selling the module on eBay, because you find lots of articles saying, well, I put this Saturn power steering unit into my Ford Mustang and it works great. And although the one guy that's saying the $35 power steering guy says that he's got reports back that this module you buy on eBay doesn't work quite right, that you don't get the, well, number one, you don't get the variable assist based on speed. And he said, your car doesn't want to return to center position. You know, normally you go around a corner and you let go of the steering wheel and it'll swing back to the center position. Apparently the way this module works, it's not allowing that to happen. I think it's because the assist is set high enough that it doesn't allow the normal caster of your front end to bring that back. But in this case, you know, if you're just trying to say control a lawn tractor, we don't really care. We just want to feed voltages in from a microcontroller and get it to drive, and then possibly have to switch. You flip the switch and then it goes back. You could drive it with the steering wheel, and you would have power steering on your lawnmower at that point. So I can go through. I put down a whole bunch of links, so I'll try to put those together and say, you know, here's different things that I found, and as I said on that one thing, that it may or may not be possible to make this work, but I'm thinking it should be fairly easy to do this, you know, once we get something that actually controls.
Thanks, Jeff. That's really good research and information. On the open source car control kit, they have an Arduino backpack that you basically put in line with your car's electric power steering, and then you can take control of that. So it allows you to either drive your car manually, or you can put it in autonomous mode and then get control of that signal. So they're spoofing the signals to be able to energize your electric power steering to control the car.
Is that a link that you just posted on the chat, or is that?
Yeah, that's in
something
the
else?
chat.
Okay.
Open source car control.
Okay. And the other thing that occurred to me was, if you can get the thing to run as a normal power steering unit, it could be you can send in signals over a serial bus or CAN bus and actually, you know, get it to go to a certain angle. But that of course assumes that you've got a, you know, steering sensor, a steering angle sensor built into it. And as far as I know, the Saturn Vue and the Chevy Cobalt type do not have that. I think it's just the torque sensor. So you'd still have to add the external potentiometer like you guys are doing. But it could be, because somewhere they said if you get a certain model of the Prius, it's got this mode built in that'll let you automatically parallel park your car. And if it's smart enough to do that, it's already going to be set up to the point where they're sending it command stick to control the steering. But I don't know how, you know, how prevalent that is. I tried looking for that on eBay, and everybody was just calling everything power assist or something. So I can't remember. I never found one that was out of a unit that does that. And if there's no information on how to do it, I guess that doesn't do any good. So I'll look into that open source car controller, because that wasn't one that turned up when I was digging. I'd go down the one line. First I'd say power steering and say, okay, here's the one guy with the $35 unit, and here's everybody else modifying their cars with the adding. They're converting from manual to power steering by adding this other thing. They all said, just go to eBay and buy that module. And so I went down that path, and then finally I finally decided they weren't going to tell me how that actually worked. And I pulled up some wiring diagrams. That was, it said something about the wiring diagram for the Chevy one is that it has a 2-wire level 2 serial data bus, I think is what they call it. Then if you search for that, then that brought up some more stuff. And I just kept digging further and further until I figured out kind of how all this stuff works. Then I just pieced it together that it doesn't work because when you power it up, it has to have something to talk to. And that's where the $50 module comes in. And it wasn't obvious. Some of them I was looking at, they seem to have more wires coming out on that guy that says the $35 electric power steering. He shows various models, and some of those have extra wires coming out, so they might have a steering angle sensor built into that. So if somebody knew a particular unit that has that, then that might be easier to just start off with that one and go with that. It just saves having to mechanically add the extra steering sensor and try to get it calibrated and so forth.
Okay. So this would be a way to give your tractor power assist, but then also you could take control of it through your computer.
Right.
And right now we're just we're bypassing all the electronics and driving the motor with a motor controller.
And that also adds the cost of having to buy that motor driver. So if you can get the one that comes with the unit originally, then that's one less thing you have to buy, and it's already integrated. So that might be a good way to go.
Yep.
And as far talking about steering, back to my mini tractor that I'm trying to do, I finally decided I need to get up the ambition to weld up a new front end. I've got the one that I made out of wood that I was using to check out the geometry and verify that it's going to work, and that turned out to be very sloppy by the time I was done, because I had to end up putting a first I had a linear actuator that runs the length of the vehicle instead of across the vehicle that I wanted, because I didn't have room to fit it in there. So I've got a linkage arm that goes from the end of the actuator. It bolts onto the frame, and the end of that goes up to the steering. And I've got several different connections there. Each one is a little bit loose, and by the time you get all those together, I could move my wheels back and forth about 10 degrees, and the actuator wouldn't move, but the wheels would move. So I decided that what I'm going to do is, I've got some more of those go-kart parts for the front axle. So I'm going to weld 2 of those axle units onto a piece of square tubing. And then I've got that Super Servo 200 like you're using for your transmission. I'm going to see if I can get that to fit in there and work. And I think I can get a fairly tight steering control using that. So that's hopefully this weekend I can get around to that. Although we're supposed to get a foot of snow this weekend, so I may just sit at home and do nothing. So, but that'll be something to try.
Okay.
And actually, this time around, I need to make it more modular. So basically, I take out one bolt and drop the whole front axle and make a new one and put the one pivot bolt back in, and it should be, fairly quick to swap stuff in and out. So that's something I'll have to try. Also on that Super Servo 200, do you recall right offhand, was there a jumper in there that you can change it from position mode to continuous rotation mode? Wasn't there something like that?
Yeah, 360.
So I was thinking that, if I end up putting a microcontroller on my Super Servo like you did, where you got that little Arduino you added on, that could also, for the extra jumpers on, whether it's the one jumper for the continuous versus position, and then it had the steering range and maybe steering centering pots that might be voltages. I was thinking if I could control those from the microcontroller, then I'd have the option that I could say, put it in a mode where I'm going to feed the RC PWM to the controller, and it will go to whatever angle I tell it. And in that case, you just assume that it's at the right steering angle. And in addition to that, I could add another steering sensor externally, so you could compare the two. But if I could send a signal to the little Arduino board and say put it into continuous rotation, then I can just treat that as a motor and then use the external steering sensor and do a closed loop feedback on that. So that would give me several different options to try out things on that. And that way you could switch them on the fly. I have a little screen that pops up and says, here's a checkbox, use this mode or this mode. And it seems like that, since it's like a research vehicle where you could have all these different parameters to put it in different kind of modes. And for the steering, that way I could switch. If I say just do the RC position and just assume it's at the right angle, or I can switch it to the other one and get my own closed loop control externally. And that way I can measure right off the steering sensor. And then likewise for the motor control in the back, where I've just got a DC motor with an encoder that's driving my back wheels, I can have several modes on that. I can normally put it in torque mode, where I just simply set it at PWM to drive the motor forward and backward, or I can put it in a velocity mode, where it'll take the speed off the encoder on the motor and do a closed loop control to give you the speed that you tell it. And what I like to do, I like to run a position mode, where I'm actually tracking the the position of the motor versus the profile that I send it. And that way, number one, it'll work a lot closer. It'll be closer to simulating a hydrostatic transmission, because once I put it in position mode and reset the thing, and it's now at position 0, and it will not move. You can push on as hard as you want. It'll fight you with everything to hold it at position 0, and if you're able to push it ahead an inch, you can let go. It'll come right back to that position, which a hydrostatic doesn't do that. But I think that's going to be the closest way to simulate that. So basically, again, then I have like 3 radio buttons on my configuration screen that says, do you want this mode, or this mode? And then I was thinking about writing that in Python with little controls on the screen with radio buttons and the check boxes and whatever. And then that could generate, you say, apply, and that would build an ASCII parameter file for ROS. So when you start up your ROS launch file, just load in that parameter file, and then it knows how to set all that stuff, send all the stuff down to the machine. So that would make it much more flexible at that point. And again, down that line, depending on what I do for GPS, if I put on that new F9P U-Blocks receiver and just use that, I could select that, or I could add that and add on one of my older U-Blocks receivers to give me heading information. Or, there's lots of different options I can use on that. So again, if you can select it from this startup screen, that would make it more useful that way, I think. So that's all I got to say about that, I guess.
I like it. It's interesting when you were talking about the steer angle, setting it on that servo, because I originally had a motor on and then switched over. I originally had the servo. The super servo was for steering, and then I switched over to the motor. And then on the transmission, I originally had a motor actuator and switched over to the super servo. But I am, on all of those cases, I am getting the feedback and then adjusting it. But that'd be interesting on your steering, how accurate you are with that, by setting it to position versus trying to control to a position.
And actually on the steering, whether you're using the RC servo and saying set it to a position or not, if you still have an external steering sensor, you can always use the external steering sensor to get your odometry information. So whether it actually set at the right position or not, the external sensor is going to tell you the true position that you're driving. So I definitely want to add some kind of steering sensor now for me to use one of those Hall effect. Like what do you call it, the body height sensors or whatever. I've got some of those. I could put one of those on, or I could put a potentiometer, or whatever it takes to make that work.
Yeah. There's I still don't have a measured accuracy of path tracking, but I've got about that 10 units of slop inside of the steering before it will the backlash, you can call it backlash, I guess. I don't know the effect of that, or if we definitely need to measure the steer angle out on that steering knuckle.
Well, I saw something else clever when I was in Denmark. I was looking at all the big machines sitting around, and speaking of measuring steering angle, I just assumed that you'd have to go to the front of your tractor. You have to mount a sensor. Say, here's your thing turning back and forth. You have to go to the pivot point and put your sensor directly over the top of that. And what they did was they had a bolt stuck up out of the top of. Here's the piece that's turning like this with a bolt stuck up out of the center, and they put a tooth pulley on there, and then they run a tooth belt over here, so they had an encoder over here with a pulley on it. So as this thing turned like this, it would turn the shaft on the encoder, so you didn't have to physically line it up in order to do that. I thought that was awfully clever, so I'll have to.
Good idea.
I'll have to look into that sometime and see what else to do. And then I see other people would, they'd mount the sensor off to the side with an arm on it, and then you have a connecting rod that goes from there to something in your steering system that's moving. So there's lots of different mechanical things you can do to look at that and figure out the right way to go on that, or just figure out something that works, I guess that's a better way to state that.
I think someone did that on his Polaris. They had the steering shaft coming down from the steering wheel, and they hooked a gear to that, and then had like a chain drive over to the encoder pulley.
Yeah. Uh, back to yours. You're saying you got 10 counts of slop in your system. Is that? Do you know where that's coming from? Is that the potentiometer? You've got a gear on your potentiometer connected to a gear on your steering. Is that where that slop is coming in, or do you know for sure?
That's a good question. I don't know for sure. The way it's set up, I've got the big tooth gear that's connected to the front steering. Then there's a pinion gear that's connected to the motor, and then I'm on the back side. I have another pinion gear that's measuring the angle as this middle gear is turning. There's backlash between turning left and turning right before it engages in this middle gear. And I just don't know if that's too much.
Yeah.
That's too much air.
You may have some. You may be able to do some mechanical adjustment. Basically turning here's your steering shaft coming down. By moving it like this, the gears on. You can get the gear closer or further away from the big gear by doing that, and that may or may not be worth a lot of playing around there. You probably are better off if you get your steering sensor right onto something where you don't have these gears in between. So whether you do, say, a potentiometer and an arm, or a potentiometer and a tooth pulley or something to measure the position, that way it's gonna, even if you have slop between your steering shaft coming down and here's your big gear out here, even if you got some slop there, it doesn't matter because you're measuring the steering right off the somewhere else down the line. Whether you do it off one of the steering knuckles in the front, or the big gear that's turning uh, in the center of the machine there, maybe just measuring that would give you what you need.
I'm going to take a look at that again, and maybe the bolt, like you're saying, put the bolt, and then I could put the potentiometer inside, or maybe there's some way to interface with that. I kept looking from the top, but I think maybe from the bottom, or put an arm on there.
Another option might be these absolute sensors that people have been talking about, and basically just put a bracket over the top of that bolt in the center of your big gear, and just glue a magnet on there, and then this absolute sensor just floats over the top of that. So as your magnet is turning down here, it measures the angle and gives you like a 0 to 360 degree output from the thing. I think it's like an I squared C output or something coming out of that. So that way you don't have to physically connect the two together. It's just, you have to get it relatively centered, but I think once you get that, I think that would take care maybe of a lot of that too. So that's something to think about, and I've never played with one of those. But
that's a good idea. I like it back protected by that metal shroud, and then that big gear in the center, those are like physically connected to the wheels, so I think you'll get a more accurate measurement there. That's a good idea.
Yeah, I think so. I think anything from the big gear out through the connecting rods, I think would be anywhere you can get onto there, I think would give you a much better idea of what your steering is.
Fun. There's always improvements, right?
Yeah. Another option would be to take your potentiometer and small gear and just simply put it somewhere else around the diameter of the big gear, so it's directly connected to the big gear and not going through that intermediate gear on the steering shaft. That way you just have one place you're going to get slop between the two. So that might help, but I don't know if it's worth making up a bracket to do that. And for the moment, since you've got it so it's drivable, even though it's got that problem, that's something you can look at later. You can go ahead and continue on with what you have, and then later decide how to fix that.
Yeah, get an estimate. I went out to the soccer field, so ground truth is kind of interesting, and measuring off path error is kind of interesting. But I went out to the soccer field, and I was looking at the straight lines on the sides, and I was wondering, maybe take 2 GPS points and then see if I could drive the white line. The white line does like wiggle a little bit on the ground, but may be a way just to get a rough estimate. Maybe put a camera down so you can see how close you're tracking on that line. Just
Yeah,
as a way.
yeah, that brings up a couple of points. Number one, how well is your GPS working? You got any better feel for how reliable it is and how accurate it is?
I don't when it's moving. I need that's another test I need to run.
And the other thing I thought about was, you know, you get all the steering built, and they say, well, how do you calibrate it? How do you know? You give it a steering angle, and you've got something in between, some closed loop thing. It's going to go to what you think that angle is. But there's always a question: how do you calibrate that? You know, how do you know exactly what 23 degrees is, or by turning it this amount, you know, what's the tractor actually going to do? And it occurred to me that if you say whatever your max and min angles are that you have set up, run it all the way, say to the left, and then tell the thing to drive, so it's just going to sit and drive in a circle. And then you can either, if you have a marker that's drawing a line on the ground, you can take a tape measure and measure the diameter of that circle, and that way you should be able to calculate back to whatever your steering angle is based on that. Or if you've got your GPS running, you can take the GPS points and just find. I think if you just take your max and min on either X or Y, that should give you the diameter of the circle. So you should be able to come up with some way to automatically calibrate this stuff without having to get out your tape measures and your chalk and all this, your protractors, which is what we've done before. And at some point, Rod figured out how to calibrate it. I think he went out the parking lot and drove in a circle, and somehow, I don't know if he measured their circle or what he did, but it just seems like there's various things you can do to automatically calibrate both the steering and this, say, the distance traveled and the speed traveled, and compare that to, say, your GPS data coming out. And number one, you can use that for initial calibration, and then every day when you start up, you can just run some little tests that would say, you know, drive straight, drive in a circle, and verify that everything is still where it's supposed to be. And if it's, you know, within a few percent, then you say, okay, we're good to go. And if not, then you can take the new values and load them back on top, because you'll find things like air pressure in your tires from day to day is going to affect it a little bit. And yeah, there's various things that are going to screw it up. So, you know, just keep in mind that there's things you could add on to make this stuff simpler and more reliable in the future.
Originally, I went out to a parking lot with like 100-foot tape, and I tried to measure everything out. I was trying to calibrate the wheel encoders, but man, that was tricky. And then, like I like what you're saying, the GPS. If you can get an accurate GPS reading, then I think that's a way easier and better method than running around with the tape trying to line everything up. Like I was trying to manually joystick to, and then you try to put the base link, your center back axle on that point on the parking lot, and it just turned out to be kind of a lot of work trying to get everything lined up exactly correct. I didn't find a great way to do that.
Yeah, that's another problem. If you line it up in a stopped condition and then you say go, now you have to worry about the acceleration and all this stuff going on. But if you're taking it off the GPS, you can just say start driving straight, and when you get to a certain point, you know, log what your encoder says and log what the GPS says, and then drive some amount, and then do that same thing again. And you can decelerate to a stop, so that way you can get around the effects of the acceleration and deceleration that are going to, you know, affect your numbers. So that's another way to. Yeah, someday we have to just write down all these things, and we can write down the stories of what we tried and let everybody laugh at that, and then say, well, here's some more things that do work, or here's some things you could try. Because we didn't have grass out in a field. We had a parking lot with asphalt. So we used a lot of chalk and a lot of tape measures, and at some point get you a laser pointer. That also helps out. You can go to Harbor Freight, or probably anybody that sells tools, and they make this little laser pointer that's got, you know, puts out the flat plane of light, puts out a line, and it's got a magnet on it. So you're supposed to stick it on like your power saw or something, so you can see where you're going to cut. But that way you can just stick it to your some of your steering stuff in the front, and then when you turn your wheel back and forth, it draws a line on the ground. So you draw it here and put a chalk line, draw it here, put a chalk line, or whatever. So it's just more things. If you think about it, there's clever little things you can do there to help out.
See, I definitely like finding your like min turn radius. You just turn it full lock as far as you can do it, and then you do a circle, and then you can measure that circle. But you know, very quickly as you, whatever degree that is, as you start to move over to straight, I mean, those circles get huge. You can no longer measure the radius of that circle.
Yeah.
So, I mean, using that laser pointer or something like that, I didn't think about that, but that's good. You need some other tools to kind of measure what's going on, or a dyno. It,
Yeah.
there's all sorts.
Yeah, I'm just thinking about all the things that we tried, and especially when we were in a hurry, we had to get this thing running by a certain day. There's all kinds of funny little things we tried, and some worked well and some didn't. So
Yeah, and also, you know, I've calibrated on asphalt and then take it out to the field, and it doesn't run anymore because of the dirt. You know, you're overcoming. Yeah, it's
yeah, well,
interesting.
hopefully all this extra stuff that we add on should compensate for that enough that it won't be a major problem. But I could get my mini tractor running to try that. So because we don't have a vehicle. It's once our one went to Denmark, we had a couple in and out, but we don't have anything to actually drive around. So I got to get either modify my car or get my mini tractor running to the point where I can go out and start doing experiments again. And hopefully the weather's going to warm up in the next couple of weeks to the point where we've got piles of snow, and it's supposed to snow another foot this weekend. And hopefully it's going to warm up, and then it's going to start flooding. So then we're going to have problems with that. But it won't be long till we can get our vehicles outside and drive them around again.
You think by April, middle of April?
I'm hoping by middle of April it'll be good enough to drive outside.
Hard to tell. That's good. This weekend I'll try to grab some RTK data from those F19s moving and then compare.
Are you doing something to keep track of how reliable the lock is? You know, are you logging data so you can come back and say, oh, it dropped off for 2 seconds here or whatever? Or do you not have anything set up to do that right now?
I don't have anything set up to do right now, but that's a really good test. I mean, if I just set them up and run, actually I have it on the lawn tractor, but yeah, recording how many times it drops off of the fix is valuable. How long?
Oh, speaking of your antenna on your garden tractor, Al and I were talking about that.
I like to have a 25-degree mask.
Yeah, because I was looking at that. I couldn't get a real good view, but it looks like at least your gas tank's in the way, and I don't know what gasoline is going to do. You got a plastic tank, you got the gasoline in it. I don't know if that's going to affect anything or not, but so that's something to keep in mind. That I like to keep the antenna above everything, just because you don't know what's going to do to it. So
yeah, definitely that needs to move up. In the middle of trying it, well, one thought is to move that gas tank down onto that base. To do that, I need to add a fuel pump and some other stuff, so that's going to be a little bit of work. And then the other thing is to maybe move that antenna or move the control box up on top of the back piece, but I don't exactly know how all that's going to fit, or make some sort of like a mounting bracket that connects everything up.
when you mounted your antenna, did you keep track of where on the vehicle I assume it's not over your base link, because I assume you have base link over your back, the center of your back axle, and I assume you're relying on then a transform to say it's really not at the vehicle center, but it's not at your base link.
Exactly.
Well, I was told when we did our latest one, I was told, well, try to mount that thing as close to the base link position as possible, because we don't have transforms built into our microcontroller code. So of course the answer was, well, we'll mount it right at the center of rotation, and I don't think it is, but it's fairly close. And somebody assured me that, well, we can write some code to do a quick transform to fix that. So So it turns out if you get to the point where you want everything mounted at your center of rotation, well, that's hard to do. That it's if you get to the point you don't want anything above your GPS, well, that's hard to do because every sensor that needs to look around needs to have a clear view. And if you get to the point where all these things are fighting, I want to be in the same spot and be able to see everywhere. So that's something else you run into.
Yeah. I thought about putting there's this kind of yellow thing that the plastic molding that goes over the engine. And I thought about putting that back on just as a place to mount everything. If we want to if we want to build some structure to haul things or to do stuff with that back part, I don't know. Or do you just, since this is just a prototype learning research vehicle, you just get it running and then deal with moving that stuff around later.
And before you go to a lot of work about putting covers and stuff back on, do a quick check and see how much vibration there's going to be. The way they're mounted, the way they originally mounted may not be as stable as you'd like. So before you go to a lot of trouble, just check that and see if that's going to do what you want it to.
Okay, that's a good idea because it's just kind of loosely, it has these kind of like slot grooves that hold that top piece down. So that could add a lot of vibration. That hammers your IMU measurements.
Mm-hmm. And it could be the way they mounted it. It could be the once it lays down and contacts the back of what was there. It could be that keeps them from vibrating a lot too. But that's something you can just check and see. Have you ever taken an IMU and used that to measure vibration? That seems like another valid thing to try. Just take your IMU and stick it onto somewhere on your vehicle and see. Look at the data coming out and see how much is it vibrating at this point.
Yeah, and then you can move it around. I've done it once with an experiment just to measure vibration, but not like you're saying, which is a good idea. It would be kind of cool. You could put it around different areas and just measure the vibration, make sure.
And it's going to be one of these things where it's not obvious. You look at it and say, well, it's going to vibrate the most here, but that may not be the case. And I think we decided on our big tractor that if we mount it right on the transmission case in the back, that you got the two axles coming out for the big wheels, that's probably the biggest mass in the vehicle, and it's all solid. So we decided that's probably going to have the least amount of vibration. And depending, if you mount it out on the front somewhere, the vibration of the vehicle, it's out on the end of a lever arm doing this, so that might be a problem there too. So that's why it'd be interesting to just check various spots on the vehicle. And while you're at it with your IMU, you could also measure your magnetic to see if, where you put it, if you're getting weird magnetic variations before you get it bolted down.
Before you commit. Right now, I put it back in that box. So I redid that box. I made a bigger box, and I put everything in there: GPS, IMU, all the controls, everything. All right.
So are you out of room in your bigger box yet, or are you still?
I am out of room. It's amazing. It's amazing. I even took stuff out, like that fuse thing. I took that out, took some other stuff out, but it's never big enough.
Well, I like Al's approach. He's got a big board that he's got everything bolted to, so it's not real waterproof that way, but he's got lots of room.
It'll make it work. Awesome. All right. Well, it's good talking with you today.
Okay.
Have a great weekend.
Well, I will, except for the snow, but well, theoretically, somebody's paid to do our snow, but they don't seem to do a very good job. So, okay, see you later.